Hi, this is a lesson in JASP and how to take a data set, a small little data set and put it into JASP for doing a independent groups t-test. I want to talk about this little independent groups t-test problem that I use for my text in Graviter and Wallnow. Basically, here's the task. Imagine that I bring you into the lab and I give you a box of tacks and a candle, and I say, what I want you to do is to mount the candle on the wall so that it will burn normally. And then I look to see how many seconds it takes you to solve that problem. And so then you have a person here. Let's call this person number 1, person number 2, person number 3, 4, and 5, who have been assigned to this condition. And person number 1 solves the problem in 128 seconds. In order to solve that problem, what person number 1 needed to do was to think, oh, okay, well, I have a box that I can use as a platform for the candle. Let me pour out the tacks, tack the box to the wall, and then put the candle on top of the box that has been tacked to the wall. Now, in the other condition, what the researcher does is he takes persons number 6, number 7, number 8, number 9, number 10, and for those participants, the researcher essentially gives them a box with the tacks already taken out. So here's a pile of tacks, here's a box, and here's the candle. And what we find is that the participants, when they already see the tacks separate from the box, much more quickly realize, oh, hey, I can take that box and tack it to the wall and then put the candle on there. Their times are far less. The average times for the people who see the tacks in the box separate is 43 seconds. The average time for the people that have the box inside, have the tacks inside the box, it takes them more than twice as long, 119 seconds. Now, how do we analyze this data in JASP? How do you put it in JASP? And the key is you don't have to number the people, but I'm going to go ahead and number the people 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Take this. I need to recognize that the box is condition 1. Condition 1 is for the first 5 people. Condition 2 is for the second 5 people. So I put in those conditions to represent the 2 groups. Now I take that data, put it in for condition 1, this data, copy, paste, condition 2, and now I've rearranged it so for how it gets used on the computer. Okay, having done that, I'm going to go over to JASP and I'm going to say that I have new data that I want to put in. Okay, and then in column 1, I'm going to write out 1, 2, 3, 4, 5, 7, 8, 9, and 10. And you can continue putting these in by hand, but I can also take from my Excel spreadsheet and copy and paste. And there's the information that I previously did. So the information from over here, I just copied and pasted into JASP. And now I'm kind of set up, but I'd lack labels on these columns, and it would be good to label those columns. So I'm going to go over here and I'm going to say these are my IDs. Let's say ID. And it's really nominal data. I mean, it's not true. It looks like a scale, but it's not truly a scale that's useful for data analysis. So apply. I'm going to go to column 2. This is my condition. So I think I'll just call it condition. And let's see, this is nominal. And I actually want to specify, I'm not seeing how to do it yet. Let's hold on a second here. Let me apply this condition. Let me go back over here. Okay, your data's in, but it's helpful to have labels for your conditions. So double left click on this. Notice that you're in column definition mode. Right here to the right of that, you can go to label editor. Condition 1 was box of tax. Condition 2 is tax and box separate. Hit that little red button over here, apply your changes. Okay, we have column 2 set up. Column 3, we just want to name the variable. Instead of calling it column 3, we're going to call it speed. Or time. Time it takes to solve the problem. And didn't take time. And there it is, finally. Sometimes JASP has a big delay in terms of enacting those labels. Okay, we're all set up for our analyses. Go to analysis. Your condition is your grouping variable. In fact, we could have called condition groups. There's 2 groups in the data set. Time is our dependent variable. We're seeing already that there's a significant effect. If you go ahead and click on descriptives, you'll see the means of 119 seconds for the people who got the box of tax together, and a much faster time of 43.20 seconds for those that did the tax and box separately. You can look at the effect size. How big is this effect? We've talked about Cohen's d, for example. And so our Cohen's d here is 1.27, indicating, sorry, it's the standard error of Cohen's d, or Cohen's d is 3.48, indicating an exceedingly strong effect size for the difference here. And I can also see plots. I like the rain cloud plots, showing you the distributions. I think maybe the horizontal display is nice. So this is showing you, here's what your distribution tends to look like, extrapolating from the small amount of data that we have for the people who are doing the box and tax separately, getting a much shorter time, taking a much longer time over here. Here's your distribution for the people that get the box and tax of tax separately. I mean together, box of tax together. Are the assumptions met? You can do it, click on that over here on the left, or test the normality assumption. It basically shows that there's no significant deviation from normality. You don't want this to be significant, so that's good. Because significance means significant deviation from normality. Is the homogeneity of variance assumption met? The homogeneity of variance assumption is about whether or not these two standard deviations are equal. They're not exactly equal. There's a bit of a sizable difference, but it's not twice as big. So this is not quite twice as big as this, so I'm not too worried about it. But if you do the test, and I'm going to go with the Levines over here, I'm finding that it is not significantly different. So like I said, lots of times it requires almost being twice as big, but it also depends upon your sample size. Anyway, our assumptions appear to be met, and that's the answer to your question. We'll stop it there. Thanks, bye.